What is cybersecurity from a developer point of view? Computing of the cloud. Cloud computing, a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Examples: network service, storage, application servers that can rapidly provision and release with minimal management effort or service provided interaction. This cloud model promotes availability and is composed of five essential characteristics: three service models and four deployment models. Cloud service models. NIST defines three service models which can be viewed as nested service alternatives: software as a service, or SaaS; platform as a service, or PaaS; or infrastructure as a service, or IaaS. Software as a service provides service to a customers in the form of software, specifically application software, running on and accessible in the cloud. It enables the customer to use the cloud's provider's applications running on the provider's cloud infrastructure. It enables the cloud to use the cloud provider's the applications are accessible from various client devices through simple interface such as web browser. Instead of obtaining a desktop and server license for software products, it uses and enterprises obtains the same function from the cloud service. The use of SaaS avoids the complexity of software installation, maintenance, upgrades, and patches. Examples of this are Google Gmail, Microsoft 360, Salesforce, Citrix, GoToX, Meet, GoToMeeting, and Cisco WebEx. And I bit him. No. Platform as a service, or PaaS. A PaaS cloud provides service to customers in the form of a platform on which the customer's applications can run. PaaS enables the customer to deploy onto the cloud infrastructure customer created or acquired application. The PaaS cloud provides using software building blocks plus a number of development tools such as programming language tools, runtime environments, and other tools that assist in deploying new applications. In effect, PaaS is an operating system in the cloud. It is useful for an organization that wants to develop new or tailored applications while paying for the needed computing resources only as needed for as long as needed. Examples of the PaaS include App Engine, Engine Yard, Heroku, Microsoft Azure, Force.com, Red Hat, and OpenShift. Infrastructure as a service. With IaaS, the customer has access to the resources of underlying connection. The cloud service user does not manage or control the resources of the underlying cloud infrastructure, but has control over the operating system, deployed applications, and possibly limited control select networks components. IaaS provides virtual machines and other virtualized hardware and operating systems. IaaS offers customer processing, storage networks, and other fundamental computing resources so the customer processing, storage networks, and other fundamental computing resources so the customer is able to deploy and run arbitrary software, which can include operating systems and applications. Public cloud. A public cloud infrastructure is made available to the general public or large industry group and is owned by an organization selling cloud services. The cloud provider is responsible both for the cloud infrastructure and for the control of data and operating within the cloud. A public cloud may be owned, managed, and operated by a business, academic, or government organization, or some combination of them. All major components are outside the enterprise firewall located in a multi-tenant infrastructure. Applications and storages are made available over the internet via secured IP and can be freed or offered at a pay-per-usage fee. The major advantage of the public cloud is cost. A principal concern is security. Private cloud. A private cloud is implemented within the internal IT environment of the organization. The organization may choose to manage the cloud in-house or contract the management function to a third party. The cloud servers and storage device may exist on premise or off-premise. Private clouds can deliver IaaS internally to employees or business units through an intranet or internet via virtual private network, as well as software or storage as services to its branch offices. Examples of services delivered to the private cloud include database on demand, email on demand, and storage on demand. A key motivation for opting for a private cloud is security. Other benefits include easy resource sharing and rapid deployment of organization entities. Hybrid cloud. The hybrid cloud infrastructure is composition of two or more clouds, private, community, or public, that remain unique entities but are bound together by standard or proprietary technology that enables data and application portability. With a hybrid cloud solution, sensitive information can be placed in a private area of the cloud, and less sensitive data can take advantage of benefits of the public cloud. A hybrid public/private cloud solution can be particularly attractive for smaller businesses. Many applications for which security concerns are less can be offloaded at considerable cost savings without committing the organization to moving more sensitive data and applications to the public cloud. Security issues for cloud computing. Security is a major consideration when augmenting or replacing on-premise systems of cloud services. Allaying security concerns is frequently a prerequisite for further discussions about migrating part or on all organizations' computer architecture to the availability is another major. Auditability of data must be ensured. Businesses should perform due diligence on security threats from both outside and inside the cloud. Cloud users are responsible for application level security. Cloud vendors are responsible for physical security and software security. Security for intermediate layers of the software stack is shared between users and vendors. Cloud providers must guard against theft or denial of service attacks by their users, and users need to be protected from one. The businesses should consider the extent of data to its subscribers and protect it against the provider, especially in the area of inadvertent data loss. The Internet of Things, or IoT. IoT is a term that refers to the expanding interconnection of smart devices ranging from appliances to tiny systems. A dominant theme is the embedding of short-range transceivers into a wide array of gadgets and everyday items, enabling new forms of communication between people and things and between themselves. The Internet supports the interconnectivity, usually through cloud systems. The object delivers sensor information, acts on their environments, in some cases modify themselves to create overall management of a large system. The IoT is primarily driven by deeply embedded devices. These devices are low bandwidth, low repetition data capture, and low bandwidth data use applications that communicate with each other and provide data via user interfaces. Embedded appliances such as high-resolution video, security cameras, video vault phones, and a handful of others require high bandwidth streaming capabilities. Information technology, PCs, servers, routers, firewalls, and so on, bought as IT devices by enterprise IT people primarily using wired connectivity. Operational technology, or OT, machine applications embedded with IT built by non-IT companies such as medical machinery, SCADA, process control, and kiosks, brought as applications by enterprise OT people primarily using wired connectivity. Personal technology, smartphones, tablets, and e-book readers bought as IT devices by consumers or employees exclusively using wireless connectivity and often multiple forms of wireless connectivity. Sensor slash actuator technology, single-purpose devices brought by consumers, IT, and OT people exclusively using wireless connectivity, generally of a single form, as part of part of larger systems. Edge. At the edge of a typical enterprise network is a network of IoT-enabled devices consisting of sensors and perhaps actuators. These devices may communicate with one another. A cluster of sensors may all transmit their data to one sensor that aggregates the data to be collected by a higher level entity. A gateway interconnects the IoT enabled devices with higher level communication network. It performs the necessary translation between the protocols used in the communication networks and those used by devices. It may also prefer basic data aggregation function. Fog. In many IoT departments, massive amounts of data may be generated by a distributed network of sensors rather than store all of the data permanently or at least for a long period of time in central storage accessible to IoT applications. It is often desirable to do as much data processing close to the sensors as possible. The purpose of what is sometimes referred to as edge computing level is to convert network data flows into information that is suitable for storage and higher level processing. Processing elements at these levels may deal with high volumes of data and perform data transportation operations resulting in the storage of much lower volumes of data. Following are examples of fog's computing operations. Evaluation, Gaudi. No. Formatting, expanding slash decoding, distillation slash reduction slash assessment. No. IoT security and privacy requirements. The requirements are defined as being the functional requirements during capturing, storing, transferring, aggregating, or processing the data of things, as well as to the provision of services which involve things. The requirements are communication security, data management security, service provision security, integration of security policies and techniques, mutual authentication and authorization, security audit. IT security management, a process used to achieve and maintain appropriate levels of confidentiality, integrity, availability, accountability, authentication, and reliability. IT security management functions include determine organizational IT security objectives, strategies, and policies, determine organizational IT security requirements, identifying and analyzing security threats to IT assets within the organization, identifying and analyzing risks, specifying appropriate safeguards, monitoring the implementation and operations of safeguards that are necessary in order to cost effectively protect the information and services within the organization, developing and implementing a security awareness program, detecting and reacting to incidents. Organizational context and security program, maintained and updated regularly using periodic security reviews, reflect changing technical risk environments, examine role and importance of IT systems and organizations, objective wanted IT security outcomes, strategies, how to meet objectives, policies, and how to identify what needs to be done. Security policy needs to address scope and purpose, including relation of objectives to business, legal, regulatory requirements, IT security requirements, assignment of responsibilities, risk management approach, security awareness and training, general personnel issues and any legal sanctions, integrity of security into systems development, information classification scheme, contingency and business continuity planning, incident detection and handling processes, how and when policy reviewed and change control of it. Management support sponsors. IT security policies must be supported by senior management needs an IT security officer to provide consistent overall supervision, liaison with senior management, maintenance of IT security objectives, strategies, and policies, handle incident management of IT security awareness and training programs, interaction with IT project security officers. Large organizations need a separate IT project security officers associated with major projects and systems, manage security policies within their area. Security risk assessment, critical component of the process. Ideally examine every organizational asset not feasible in practice. Approach to identifying and mitigating risk to an organization's IT infrastructure. Baseline, informal, detailed risk combined. Baseline approach. Goal is to implement agreed controls to provide protection against the most common threats. Forms of a good base to further security measures. Use industry best practice. Easy, cheap, can be replicated. Gives no special consideration to verifications of and risk exposure. Maybe give too much or a little too secure. Generally recommend only for small use organizations without the resources to implement more structured approaches. Informal approach involves conducting an informal pragmatic risk analysis of the organization's IT systems, exploits knowledge and experts of analysts fairly quick and sheet. Judgments can be made about vulnerabilities and risks that baseline approach would not address. Some risks may be incorrectly assessed, skewed by analysis views, and varies over time. Suitable for small to medium shared organizations where IT are not necessarily essential. Detailed risk analysis, most comprehensive, assess using formal structured process, numbered stages, identify threats and vulnerabilities to assets, identify likelihood of risks occurring and consequences, significant cost of time, resources, expertise may be a legal requirement to use, suitable for large organizations with IT systems critical to their business objectives. Combined approach combines the elements of baseline information and detailed risk approaches aimed to provide reasonable levels of protection quickly as possible, and then examine and adjust protection controls deployed on key systems over time. Approach starts with the implementation of suitable baseline security recommendations of all systems. Next, systems are either exposed to high risk levels or critical to the organization's business objectives are identified in the high level risk assessment. A decision can then be made to possibly conduct an intermediate informal risk assessment on key assessments with the aim of relatively quickly tailoring controls to more accurately reflect their requirements. Lastly, an order process of performing detailed risk analysis of these systems can be instituted. Over time, this can result in more appropriate and cost-effective security controls being selected and implemented on these systems.